Hello pre-calculus students, and welcome to a first video on conics. So this is an introduction to conics, and what we're going to do for the most part here is we're going to focus on this in an analytical way. We're not going to really see the shapes quite yet. We're going to focus more on what we do algebraically to get to where we can see the shapes. So this looks like a complicated mess. So let's see if we can sort out what we're trying to do here and what all of this chart is saying. Okay, so first of all, the goal, the objective. So the objective is to recognize the general form of a conic section, determine which of the four conic shapes is represented, and then complete the square in x and y, and then write it in graph-ready form. And then starting tomorrow, we'll start graphing. Okay, so first of all, there's the very top of this is the general form. This right here, this equation, this is the general form of a conic section. It's generally got it doesn't always have both A and a C, but unless it's a parabola, it's got both, and we'll talk about that in just a second. That's actually how you can tell you're looking at a parabola, so we're always going to look at those to be able to tell. Now, just so you know, if you're kind of looking at this and thinking, well, that's kind of weird, there's an A and a C, but there's no B, so the reason that there's no B is because we're not going to include B. There is a B term in the general conic section, which represents a rotation, but we're not going to look at rotated conic sections. We're just really getting an introduction here, so we're only going to look at conic sections that are moved around and stretched, but not rotated. Okay, so that's why there's no B. All right, so let's look at this column right here. Now, this talks about A and C. Everything here talks about A and C. So in other words, when you're trying to decide which of the four shapes you're looking at, and you're probably familiar with the first three, and you may or may not be familiar with the fourth one, the hyperbola, but we'll talk about that in a lot more detail throughout the week. Okay, they're always looking at A and C to decide which conic section you're looking at. In other words, you're always looking at the square terms. All right, if they're both there, then you don't have a parabola. You have either a circle, ellipse, or hyperbola. If only one of them is there, in other words, if either A or C is 0, that means only one of the terms is there, then you're looking at a parabola. All right? If they're both positive and equal to each other, you're looking at a circle. All right? If they're both positive and equal. If you're looking at two that are positive but not equal, that's like a stretched out or distorted circle, which is called an ellipse. All right? And then if you're looking at one of them being negative, either A or C is subtracted or negative, then you're looking at a hyperbola. So let's look at some equations and see if we can figure out which ones we're looking at. All right, so this first example, we can see that something's missing. There's no x squared term. In other words, there is no A. A is 0. So this is a parabola. So this first one's a parabola. All right, let's look at the second one, and we're going to write them in, and you can try the rest. So these are both positive, they're both there, and they're both the same. So that's a circle. Okay? See if you can identify the other three examples, 3, 4, and 5. I'm going to pause them and write them in, but there they all are, and give it a try. Okay, so here we go. So the first one, because it has a negative, anytime either one of the x squared or y squared terms is negative, that's always a hyperbola. All right, and that's represented right here in your description. It says if A or C is negative. Okay, so it's pretty clear if you need to refer back to that. Here they're both positive, but they're different. Positive and different means you're looking at an ellipse, right? They're different, they're not equal, but they're both positive. That's an ellipse. And then the last one here, they're both positive and they're both the same, so that's another circle. So we're looking at parabola, circle, hyperbola, ellipse, and then one more circle for our examples. We probably won't do all of them right here, but we'll definitely do 4. Yeah, we should be able to do all 4. All right, let's look at this first one. Okay, now our little pointer here for a parabola is if A is 0, which is what we have for the first example, we're going to solve for x, complete the square in y. Okay, so let's do that. So let's solve for x. So I'm going to isolate my x right here. I'm going to add this, subtract this, and add this. So I get 2x is equal to, and put them in descending order. So it's equal to y squared minus 8y, and then add 6 to both sides like that. Then we're going to divide both sides by 2, so we get x equals 1/2 y squared minus 4y plus 3, right? When we multiply, if we divide both sides by 2 or multiply by 1/2. So this is 1/2 y squared minus 4y plus 3. Okay, we're on our way. Now, the next step is the tricky step. We have to be really careful here. And that is that we're going to put this aside. We're going to ignore this for a minute. I'm literally going to move it over to the side. And we're going to factor out the 1/2 so that we can complete the square in y. Now, when we factor out the 1/2, we have to be really careful. So we take the 1/2 and we have to figure out what do we actually multiply by to get this back. Well, y squared is the easy one. But what do I have to multiply 1/2 by to get negative 4y? It's got to be minus 8y. So I have to put minus 8y here. All right, so far, if I were to distribute this, I would get that. Hopefully you guys agree with that. Now I'm going to leave room to complete the square here, and then I'm going to close the parentheses and leave that plus 3 alone. And you'll see why once we finish this. You might have done this in Algebra 2. Okay, so now we're going to complete the square on y inside here. And so we always do the same thing. Okay, we take half of the b term right there, half of that, and we square it. Half of negative 8 squared is positive 16. All right, now I don't really want to add 16 and change my equation. What I want to do is I want to add 16 and rewrite my equation. I don't want to change it. So I got to think about this really carefully. What am I really doing here when I add 16 is I'm really adding 8, right? I'm adding half of 16 because I added it to the inside of the parentheses. Again, you'll see why in just a second. So if I added 8 and I want to not change this, I've got to subtract 8 on the outside. Okay, so I'm going to underline that. So see, they kind of go together. Even though they don't look the same, they do go together. All right, now the reason that I did this is now a perfect square. So I have 1/2 times y, and whatever half of the b term is, the thing that you squared, in this case negative 4, that's what you take out from there, y minus 4, and that's the perfect square. If I multiply this back out together, y minus 4 times itself, I'm going to get what I found there. Right? And then I have minus 5, just combining like terms. Okay, and there we are. That is now completed the square. I can now see my HK. I can see my vertical stretch. And this is graph ready. And you guys know how to graph this, except it's sideways. But for the most part, you do know how to graph this. So let's just write this in to our completed the square step here, which is step B. Complete the square in x and y, or x or y in this case. And so we get x equals 1/2 of y minus 4 squared minus 5. Okay, there we go. It's actually the hardest kind is a parabola, but that is already, the good news is that's already in graph ready form. Like you said, I told you, I reminded you guys, you already can see the vertex right there. So we've got x equals 1/2 of y minus 4 squared minus 5. And we'll talk about graphing tomorrow, but that's it. We're done with parabola. All right, let's look at the next one, which we've identified as a circle. A little bit easier, and it's the other three are different from the parabola. So you'll see how in a second. So what we're going to do here is we're going to first rearrange these. Now it does tell you here, rearrange the terms for circles and ellipses so that we have the x terms together and the y terms together. Get that constant on the other side. So whatever it is, we're going to just subtract it or add it to the other side, depending on whether it starts out positive or negative. So let's do that now. So we're going to group together the x's. Oops. So we have 2x squared plus 38x. Group together the y's, so plus 2y squared minus 42y. I'm just rearranging the order of the terms. And then subtract that 329, so I have equals negative 329. All right, that's the first step. Next thing we want to do here is we want to factor out the 2 just like we did before. So we have to be really careful with this step. But basically we have to take out the 2. So 2 times something to equal 38x. So I have an x, well, the x squared is easy. Now 2 times what equals 38, and that's 19x. 19x. I'm going to leave space to complete the square, close the parentheses, do the same thing with the y's. Take out the 2, so plus 2 times y squared minus 21y Leave room to complete the square. By the way, completing the square will always be added, so you may as well put that plus sign there. All right, equals negative 329. All right, now what do we do to keep this balanced? Well, I'm going to add something here, so I'm going to add it to the other side. It's actually going to be twice as much because whatever I add, I'm multiplying it by 2. I'm going to add something here, so I'm going to add another thing to the other side. So I'm adding a bunch of stuff to the other side, and now let's write this as completing the square. All right, now what makes this one a little bit harder? That 38 is a fraction. I mean, half of that 19, sorry, is a fraction. So when I take, in other words, half of b, which I always take, I have to take half of this and square it. So I'm just going to say 19 over 2 squared. 19 over 2 squared. Half of this is also a fraction, so I'm going to take 21 over 2 squared. All right, so what am I actually adding to both sides? I've got to be careful here because when I square this, my denominator is a 4. When I square this, I get 381. So this is 381 over 4. Multiply that by 2. And you might have to pause this and rewatch this, okay? But 381 over 4 multiplied by 2 is 381 over 2. So that's what I'm actually adding here. That's what I have to actually add over here. 361 over 2. So 361 over 2. All right, now let's do the same thing with this one. 21 squared is 441. This is 441 over 4. Multiplied by 2 is really 441 over 2. This is, I got rid of the square, okay? So I'm just going to show you. So I have 441 over 4, and I multiply that by 2, I get 441 over 2. All right, so that's what I'm actually adding to the left side of the equation. That's what I have to actually add to the right side. It's 441 over 2. Okay? Fun with fractions. I know you guys don't love the fractions, and there won't be many. I don't want to show you an easy one and have you get the harder ones for homework. So I'm just showing you the ones with the fractions. Okay, so what are we doing next? So we have completed the square. So we just have to write it now as a perfect square. So this is 2 times x. This was added. This is a positive, so it's 19 over 2 squared. In other words, if you were to multiply x plus 19 over 2 times itself, you would get this trinomial that we had up here. Okay? The square and r, right? There's the 19 over 2 squared right there. All right, same thing for this one. So plus 2 times y minus, this time it's minus 21 over 2 squared. All right, and that equals the sum of all this stuff together. When we add all this together, we get a nice number. We actually just get 72. Try it. Okay, 72. Okay, so we're just about done. We have completed the square, and we can now write this as finishing completing the square. That's part B. That step B is done. So this is going to be 2 times x plus 19 over 2 squared plus 2 times y minus 21 over 2 squared equals 72. All right, now let's go and look at our third step here. If it's a circle, which this one is, and a and c are not equal to 1, if a and c are not 1, they're going to be the same because they started out the same. Then divide both sides of the equation by that number. So let's see what we have here. We're talking about these 2's right here. That's all we're talking about, these 2's. So we divide both sides by 2, and we get x plus 19 over 2 squared plus y minus 19 over 2 squared equals 72 over 2, which is 36. We like that because you may remember that with a circle, that's our square, so that's our radius. And you may remember that that's our center. Okay? Let's pause and we'll do part 2 with the other 3 examples. Hope you found this helpful.